All right, today what we're going to do is look at section 9D, displaying and describing numerical data. So last time we looked at how to display categorical data. Remember, categories are either nominal or ordinal. You're just getting the name of an item, or you're getting some category to put it in where you could rank them. The big deal about those was you did a frequency table, right? And then after you did the frequency table, then you turn that into a column or bar chart. And you're going to see that it's very similar for numerical display data, numerical displays, except that the bar charts are called histograms. And the only difference is the bars touch. So remember, with a column graph, the bars could not touch because one piece of data wasn't related to the next piece of data, so they couldn't touch. But this is numerical data, and numerical data flows along in order. Okay, so the bars can touch in this case. So what you're going to have is you're going to have bars or columns representing numbers or a range of numbers. And which one you choose is going to depend on the data that you're working with. Say you were just looking at answers 1 through 5. Somebody was going to rank things 1 through 5. You could do a bar for each one of those numbers 1 through 5. But say the rankings went 1 through 1,000. You would not want 1,000 bars going on. Instead, what you would do is you would group the data in some more manageable chunks. So for example, if you have the 1 through 1,000 example, you could do 1 through 99, 100 through 199, etc. So they're nice, even clumps. The only thing that you must make sure of is that you have exactly the same number of numbers in each set of data. So each one of the bars has to be exactly the same width. And notice that it always starts with the nice clean number. So you wouldn't stop it at 145 and then start at 146 or stop at 146 or something strange like that. So make sure that you're always starting with a nice even number. Okay? How you divide it, totally up to you. So if we had 1,000 of them, this would make 10 bars. That's a lot. So we could do it in 200s. Okay? Well, just depends on how they divide. Okay, so started at a nice even spot, and then the ends can kind of be ambiguous with the 99. So just make sure that you're clumping them all in groups that are the same size. So we're just going to go to the book and look at a couple of these real quickly because you're going to see they're not much different than creating the column graphs that we did last time. So first we're going to start about looking at a frequency table. Again, the only difference here is that you have numbers instead of words. So you just have a bunch of numbers there, constructing a frequency table. You still get a title, but this time you're reporting numbers instead of names. So the title that you get underneath, you don't have like sandwich, pie, etc. You have all the possible numbers that can happen. In this case, 0 through 6. Right? So watch out for any constraints that they give you as far as numbers. Here they say the minimum value is 0. If you look at your data, the minimum value is 0, the maximum value is 6. So we only need the numbers 0 through 6. If it went 0 through 10, we'd have to include more. Right? So just always find the smallest value and the largest value first so you'll know how many digits are available to you. All right. Then, just like last time, you have the frequency and a total of all the numbers, and then you change those into a percent by putting the number of times the frequency over the total numbers. So that doesn't change at all. All right. So again, the frequency table doesn't change much except for the way you label things. Now, when you look at The data and the way you organize it, you can also have a range of things. So here we have a group of 20 people. We're asked how many cups of coffee they drank, and you see that there were 20 people, so they just broke it up into 5 digits. 0 is a digit, so that's why it's 0 through 4. Remember, be careful, that's 5 numbers, right? 0, 1, 2, 3, 4. Then 5 through 9, etc. Okay? And making sure that you go far enough that you get the maximum value on your chart. You don't have to go any further. Now, if the maximum value on the chart doesn't fall at the very end, that's no big deal. But if you start in groups of 5, then you have to go groups of 5 all the way down. Okay? So that's what a range looks like. And then you just do the tally and find your numbers. And then finally, you're going to use that frequency table. Okay. Sorry, for continuous numbers. So all of those numbers were discrete numbers because if you get a cup of coffee, you get a cup of coffee. It doesn't matter how much is in it. It still counts as 1 cup of coffee. But here we have some decimals. They could be fractions. In this case, they are continuous data. So in other words, your number can be any fraction or any decimal. And in that case, notice that they do the ranges by including that 1 decimal place. So these are continuous data. Not much difference. Just make sure that if you have them, make sure you include them. And now look at the example of the frequency table of this. We have frequency and the number of siblings. So this is the table for the first one. And you'll notice that the only difference between this one and the other one is that because we're working with numbers, the numbers can touch. All right? So this is called a histogram instead of a column graph because what's happening is you can read what's happening over time using one of these. For continuous data, that just means that instead of getting individual numbers, you just have ranges of numbers. And notice that only the number that begins the range is put on your chart. So it started at 170, then the next one started at 175, so that's the next boundary. So these boundary points are what you're going to put on the chart, not the range of numbers. And again, because they are continuous, you're just going to get bars that touch. All right? So grouping in ranges of numbers and having the bars touch are the only difference. Okay? All right.